Hi everybody, this is Alan, and in this crash course you are going to learn what APIs and web APIs are, why we use them, and you will also see how to create web APIs in ASP.NET Core and how to work with them. We will start with an introduction to APIs and we will see how our files are structured. Then we will create a web API project using the CRUD Operations, and we will see different relationships between our models when we work with web APIs. We'll end the course with a project in order to see how we can call our own web API, and also we'll make an extra small project on how to integrate ChatGPT in our applications. So let's just get started. API, first of all, stands for Application Programming Interface. An API is a set of rules, protocols, and tools that allow different software applications to communicate and interact with each other. APIs can be used to access the functionality of an application or service, retrieve data and submit data, perform operations, or integrate different systems together. Web APIs, on the other hand, are APIs designed for communication on the web and are typically based on HTTP protocols. They enable applications to interact with web-based services, access resources, and retrieve or manipulate data. Developers can access web APIs by making HTTP requests to the API endpoints using different programming languages. The API will process the request, perform the necessary operations, and return a response, usually in a machine-readable format. This allows applications to leverage external services, integrate third-party platforms, or even build their own APIs to expose their functionality to other developers. Some useful and popular web API examples are Google Maps API, PayPal API, and OpenWeatherMap API. Google Maps API provides developers access to mapping and geolocation services. It allows you to embed maps into your applications, get directions, and many other location-based features. PayPal API allows developers to integrate PayPal payment functionalities into their applications. It enables you to process payments, create and manage invoices, retrieve transaction details, and perform other PayPal-related operations. There is also OpenWeatherMap API, that is an API that provides access to weather data and forecasts for various locations worldwide. It allows developers to retrieve current weather conditions, 5-day forecasts, and many weather-related information. Before we move on to the next section, I just wanted to remind you really quick the ebook that I just launched this last week. I wanted to write a C# handbook with all I know about C#, and I wanted to provide you with the right way to learn the language. So I will leave the link down below, and I would really appreciate it if you check it out and let me know what you think about it. Now let's just keep going where we left off. In this section, I'm going to show you how to create an empty web API project, and we're going to see briefly the files structure, how things work, and we're also going to talk about Swagger, which is essential to designing, testing, and documenting our web APIs. So firstly, let's just create a new project. In the templates, we're going to search for an API, for a web API template. I clicked next way too fast. Here we can select an ASP.NET Core web API with C# as its language. Let me just give it a name to the project as usual. Most of the things will leave as default. And here, where in enable OpenAPI support option here, this allows us to have Swagger in our project. This installs a few packages in order for Swagger to be part of our project, which we will see shortly. And we'll just wait till the project loads. Okay, so here you can see the file structure, which most of the files are usually the same as the ones that we have in an MVC project. So we have the connected services, dependencies. If we click on dependencies and on packages, we see these two packages that we have installed in our project because we selected that enable OpenAPI support. And In the controllers, we can see the weather forecast controller, which is just like a default controller that it's created by itself. In app settings.json, as the same, is the place where we connect the project to the database. And then in program.cs, here on top, we see that we have added a service, the add swagger gen, which basically generates the swagger for our project. And a bit below, we specify that only if the application is in development, we use Swagger and we use the Swagger UI. Here we have the weather forecast class, which is basically just a model, just like the models, which have the structure of the data that we have in our APIs. So here, the controller, we can see here that it's specified to be an API controller. We have the route name there, and this may seem a bit complicated, but basically what this does is just creates some data to return to our API. So here the get method here just creates an object, a weather forecast model object, and it creates a random date, a random temperature, and a random summary, which is one of these weather properties in the array above, and it returns it as an array. So this is just to have some data in our APIs, and if we run the project now, the Swagger will appear. So in our web API projects, we don't have view pages, but we have the Swagger. And Swagger basically is just like a set of tools that helps us a lot to design, to document, and most importantly, to test our APIs when we create them. So this is how Swagger looks like. On top we have the name of our project and the version 1.0 as a default one. And below we have the swagger.json file, which is basically the file that contains the raw format of the APIs that we create. Then we can see a section to select a definition, which basically means that we can select the version of our APIs, because sometimes developers have the need to create different versions of their APIs because they do updates to it or fix stuff. We only have one project, so that's the default one. And down below, we can see the controller name and the get method that we have in that controller name. In that controller, if we click on try it out and then click on execute, basically what we are doing, we are simulating an HTTP request to our web API. The HTTP request has three parts, which are the request line, which is this get HTTP method here, and the address of our web API. The request has a header section, which is this accept, the type of a text or input that it accepts. And it also has a body section, but it is optional, and in our case we don't have any. And then our web API returns an HTTP response to us. An HTTP response has a status line, which is this 200 code here. And down below, we see that it means success. The HTTP response also has a response body section, which is all this data that we created in our controller, that were already created in our controller. And it has also a response header, which is this content type, date, and the server, some information about the HTTP response. Down below, we have also the schemas of the application, which are basically just the models. We see here the weather forecast model. So these were created by the project by default, but here usually are stored the models of the data that we create in our project. So they just show the structure of the data that the APIs have. In this section, we're going to be creating a web API project with the CRUD operations. We're going to be performing these main operations in order to learn how to work with web APIs. We're going to be using a service to interact with a database instead of doing this inside the controller. And we are also going to see many other concepts such as data transfer objects, among other things. So firstly, we're going to need to create a new project. We're going to need to select an API template, an ASP.NET Core Web API with a C# as the language. Click on Next. I'm going to need to give the project a name. Okay, click on Next. We'll leave this by default as they are. And we're just going to need to wait until the project loads. So this is our project. So what we can do first, we can add a folder to add the models. We're just going to create one model. And so I'm adding a class in the models folder, and I'm just creating, I don't know, a user's model. I mean, APIs can be about anything, about a bunch of different things. So I'm just going to create a simple model here. So it will take an int ID property. A string name, or I'm just going to write it as a first name. And then I can create a last name property. And the public int personal number. I mean, just some data for a user. We can make here the first name and the last name as nullable, just to remove those errors there. I would have just left them as they were. But what we're going to need to add now here is I'm going to add the data folder so that we create the context. So I'm going to add the class inside of it. And I'm going to put a name for the context. So like CRUD, the API context. Normally it should be something, I'll make it a bit shorter. Okay, so this is our context class. This needs to inherit DB context, which I don't think is known because we should have installed something before, the entity framework core. So find and install the latest version. But we can also go to dependencies, manage NuGet packages, and we can install a few other packages that we need. So these were the packages already installed by default by the project template. And what I'm gonna need is just a couple more packages that will enable us to make interaction with the database. So the first one is going to be entity framework core .tools, which allows us to add migrations and this bunch of operations here relating the database. So accept. Okay, this was installed. The next one is going to be the SQL Server extension, so that we can connect the project to the SQL Server database. And I'm going to click on install here, accept. Okay, so this was also installed, I guess now. So we can go back to our context. Okay, so we need a constructor inside the context, which is going to be API context. So it takes a bunch of parameters inside of it. You can see this in the documentation or just copy this as it is. So I don't learn this by heart. I just open the documentation to see these arguments that the context constructor takes. And here down below, for each model that we create, we also need to create a dbset instance of that model. So for the user, and we'll name it users. And I think I need to import the models here. Okay, everything is fine. So the context basically connects our models to the database. And as we've already explained, and I'm gonna need to create a database and just go to View, Server Explorer, and click on top here, create new SQL Server database. I'm gonna need to open the SQL Server Studio to get the server name that I have. So this was loaded. I'm just gonna copy here the server name, and I'm gonna paste it here. Just put here a name for the database, just like whatever. Okay, so the database was created, and here in the property window, we can copy the connection string, which is the physical location of the database, and we need to write it here in the app settings.json file. So connection strings inside of it, I'm putting a name to the connection string, like a default connection string, but the name doesn't matter. You can put whatever you want there. I'm pasting down here the connection string, and here I'm going to write encrypt. I'm going to set encrypt to false, because when we connect to the database, we don't have any password or so. And what's left to do is go to program.cs. Here in program.cs, we're going to need to add it as a service, the context. And so builder.services .add db context. Okay, so inside of it is going to be the name of our context. So options that use SQL Server, and inside the parentheses here, we're gonna actually specify also the connection string name. So builder.configuration that get connection string, and we'll put here the name of our connection string. So this is just some routine stuff, the way that we set up the database. You don't need to learn many things by heart, but okay, so I forgot here I think I've forgotten something here. It gives me an error. Okay, so the name of the context was API context, not CRUD API context. And things look okay. Okay, now we just need to add the migrations for the model that we created, for the connection string, for the context instance. So just add migration, a name there to the migration. Okay, build succeeded. Here we just need to update the database now. Okay, so now things look good to go. We're gonna delete this default controller that there was there and this default weather forecast class. Okay, so we need to add a controller and we'll click on API and create an API controller empty. So this is the template. I'm gonna name it users controller since it's the name of the model. And here's our API controller. So here we're gonna create a service in a bit, and here we're gonna add a variable to access that service. And we will create here the constructor for this class. And we'll give here, so we'll give this service variable the value of the service. So in just a bit, we're gonna create this service that I'm talking about. But here I'm just gonna start writing the name of the first method, which is gonna be an public async task. It will return an iAction result. And it's gonna be an enumerable of users. The name of the method is going to be get users, and I'm not writing here again the value that the enumerable takes because we're not going to be using users actually. So in web APIs, a concept that we'll usually use are DTOs, which are data transfer objects that basically are just a subset of a model that we have. So we can go to the root project directory and add a folder. I'm naming it DTOs, which were data transfer objects. And inside of it, I'm adding a class. I'm naming it user DTO. And what DTOs allow us to do is they are basically just a subset of a model. So when we don't want to show specific information about our model or just want to separate it into different parts, so we only want to show one part or something like that, we use DTOs. We will be using them a lot in web APIs. And in our case, for example, I'm just copying everything from the user model except of the ID, because okay, so I'm just gonna make it so we don't show the ID because the ID is actually something sensitive. So the user won't show the ID when they create a user, when they access the API, or when we take the information from the API, we won't see the ID of the user. So the return type here is going to be user DTO. Okay, I just imported there the DTO directory. And in the data folder, we will create, firstly, to create the service, we need an interface. And I'm going to name it iUsers service. So this interface will just pretty much select the signature of the methods that we're going to write in our service. So the first method is going to be a task. It will return an enumerable of user DTOs. And the name, I'm going to put it get all. So the reason why we do the services basically is just, okay, so I'm importing here DTOs directories. So I'm going to add the folder of services, and I'm going to input here the interface and the service inside this folder. The reason that we write services, as I was saying, is just that it's not a good practice to access the context or the database from the controller. So we do this inside the services. So accessing, getting data and putting data in the database is better to be done inside the service. So that's the whole reason we're doing it this way, as we have talked about it before also in MVC. So here I'm gonna create the user service .cs, and this service is gonna implement the iUser service. If we click on the show errors and implement methods, we're gonna see this method implemented that we had in our interface. So I just wrote async in front of it, and okay, we're gonna need a variable to access the context. So private read-only API context, I'll name it underline context as a practice. And of course, here we're creating the constructor. And as I've said, we will use user DTOs. So to return data in that format, so I'm gonna need a method here, which is gonna take user, which is gonna return user DTOs. I'll name it user2DTO. And what this basically will do is just take a user object and return a user DTO object. So, okay, this is gonna be the form of the method that I'm creating here. So this function will create a new user DTO, and what it will have, the first name of it will be the user's first name, the last name of the user DTO will be the last name of the user, and so on. Because we're gonna be using this thing in all of our methods below, so that's why we are using a function on top of it, so we will have it easier to use. So to turn users into user DTOs in all of our methods. And we can just now start working with our first method. So we'll return await context.users that select. So in the users context, we'll select from all of the users. So we'll take each user and we'll perform this user2DTO function to them, or method to them. So then to list async. So the reason for the mistake is that in the function created above, it should take a user as a parameter, not a user DTO. So I'm gonna import here the modals, and it should just work fine now. Okay, so I was missing one importing entity framework core on top. There are no errors now. And we can go to the users controller, and here the service, okay, we'll import these services, data.services directory. and the service should work now. And just go and handle our first method. So we'll write a variable of users, and this will take all of the users in form of a DTO. So we will await service underline service dot get all, and this method will return us all of our users in a DTO form. And in web APIs, we will return an OK response, and which will take users as well. The return OK users basically just means that everything is okay, so it returns a 200 code response in the HTTP response, and it returns the users as well. This is just some basic return type in web APIs. We will see also the other ones, how they what we return in the other cases. Okay, so when we run the project, if we try to get all of the users, we will probably see an error because we haven't added the services in our program.cs, which we will do now. So here we will add builder.services that will add our services as scoped. So add scoped, and we'll write here the name of the interface and the service. And this will basically be it. If we run the application one more time, we should be able to get all of our users. But of course, since we haven't created any users yet, we'll basically just see an empty array, I suppose. So we can click on try it out, execute, and as a response body, we have an empty array, but the code is 200 because the response, HTTP response were a success. So yes, we can just go ahead and create the rest of our methods in our controller. So the next method is going to be an HTTP get to get the items, to get just one specific item or one specific user. And these HTTP get tags will have an ID here, which basically what this ID here means is just that when this method is invoked, whatever the ID is in the URL of the API address, the ID will be passed into the method. So basically in the parameter of the method. Okay, so we can go and write our signature method here, which is going to be task. It will return a user DTO. I'll name it get by ID. And it will take an int ID as a parameter. Okay, we'll implement here the interface or that specific method. We're going to make it asynchronous. So what we're going to write here, we need the variable for the users to store the users. And we'll take from the context the users that find async, which takes the ID as a parameter. This has to be an await process, and we will return the user variable as a DTO, so we'll use this user to DTO function. And we'll go back to the controller. And here we're also gonna need to store, to create a user variable. And here we will store what we will get, the user DTOs that we will get from the service that get by ID method that we just created in the service. And we just need to make a short if clause here. So if the user is null, we will return like no contact. We will return no content or not found actually, which will be a 404 code. And if everything is okay, we'll return an OK response code with the users as a parameter. So we'll get the user returned as well. The next method we're going to be handling is going to be the HTTP put method. It will take also an ID. In order to take the ID for the specific user, so public async task, no object will be returned, and the name of the method will be put user, and it will take an int ID and the user DTO as a parameter. Okay, so we need to go back to the iUser service interface, and here at task user DTO will be the return type, and update, I'll name the method. It will take an ID and a user DTO as a parameter. If we go to the user service here, we can implement the method or the method signature. Okay, so in this user variable, we will store the specific user that we are talking about, so that we need here. So users that find async ID, and we'll make an if clause here. So if the user is not null, so what we're gonna do here is we're gonna assign to the user. So to the user, we're gonna assign the values of the user DTOs that we take from the parameters. So when a user inputs some data, it will input the data as a user DTO, and we will take this and convert it to the user, and then we will basically save this user to the database. So we need an await context that save changes async to store the changes to the database, and we will return the user DTO again. So this was it. If we go to the controller now, we will take in a user variable, we will await underline service that update, which will take the ID and the user DTO. So the user will be updated, and will be a user DTO will be returned. And if this user variable is null, will return a 404 code or not found code. Else we will return an OK. Else we will return no content at all, which is some other code. Actually in APIs, but so we don't need to return anything. Okay, so we have our last two methods to create. The first one is going to be an HTTP post, and it will be a public async task to return action result and a user DTO, it's going to be a user DTO, and the name of the method is going to be post user, and it will take as an argument a user DTO, which will be inputted by the user by us. So the next step is again to create the method signature in the interface. So it will be a task, an asynchronous method. It will return a user, and I'm going to name it add here. It takes a user DTO as a parameter and it returns the user. So I need to import the models directory in this interface, and here we can implement what we just created. So in this, we write as usual user variable, and here inside of it we will create a new user. So we'll take a user DTO as an input from the person who uses the API, and we'll create from it a user. The first name of the user will be the user DTO's first name, and so on. So basically, when the user creates a user, it creates actually a user DTO because he doesn't specify the ID, and we will take that and turn it into a user and create a user. So in the context, we'll add this user that we just created, and we'll just then save the changes and also return the user. That was it. Just go to the controller. So inside this user variable, we will store the result of the method in our service. So we'll add the user DTO to our database, and the return type in this case, so when we create a resource, so when we create a user or something else, we usually write this created at action, and what it does is that it returns an HTTP 201 status code if what we wanted to create was created successfully. And what it also does is that it adds a location header to the response. In the location header, I specified some data about what we created. So like the method where you can access it, its ID, and what it is that we created. Okay, so our last method is going to be an HTTP delete method, which also takes an ID here. So public async task, it returns an iAction result. It basically just doesn't return like an object, and the name is going to be a delete user. And it will, of course, have an int ID as a parameter. We'll just need to go to the iUsers service. And the signature of this method is going to be, of the method that we're going to create, is going to be task, delete, and as a parameter, an int ID. So basically it just doesn't return anything. Okay, let me just find it. Okay, I'll make it an asynchronous method. Here, I'm going to just create a user variable. Here, I'm going to, in the context, .users. So here, I'm just going to find the specific user. And if the user is not null, we're going to be deleting that user. So underline context .users.remove user, and then we're just going to need to await to save the changes in the database. And that is basically it. We're just going to need to write a few lines here. So to implement that method from the service. So just await underline service.delete, and it takes the ID. And we'll just return no content at all because we don't need to. So in the HTTP response, there will be nothing returned. So no content. And if we run the application to test all of our methods, you will probably just understand them a bit better. So before we try to send a request to the get API users endpoint, now we're going to try and create a user. Here we will create a user DTO actually, because we won't be inputting the ID. So just like James Gordon, some value for the age and for the personal number. And if you click execute, the user will be created in the database. And this is the content, what the HTTP request contains that we created. And the response will be this 201 code, which basically means that the resource was created as we were doing before. The response body tells us the information of the object that we created. And if we see in the response headers, we see this location property here, which tells us the location of the user that was created. And we talked about it here when we created the post user method in the return created at action. And this was what this method did. So it just also returned the location header to the response with the data of the user that we created. Okay, so we created the user. We tested this API endpoint. We can go ahead and test the get ID endpoint. So we'll put one there, execute. And in the response, we take a 200 code, a success code, and this is the object that was in that address. So if we go back and see here what we did in the get user method, we searched for that user and we returned OK, the 200 code, and the user in the response. So yeah, I mean, if you check this and check what these methods do, you will probably just understand them a bit better. So if we try and update something in the put API endpoint, I don't know, I don't remember what I wrote before, so I'm just gonna be replacing all of this. But yeah, we inputted there the ID of the user, and here we will update it. If you click on execute, so the new user was created, or it was updated. If we go to the put user method, so here we take the ID and the user DTO, we update it, and we actually return no content, which is this 204 code that we saw here, if everything was successful. The last one, what we could actually try, I think, okay, if we try the get all method here, or the get API endpoint, it worked again. And what is left for us to do is to try and delete something. So in the delete endpoint, we click the ID of one, and we take a response of 204, which is a response of no content. So we deleted the user and we return nothing. If we go to this get API users endpoint and check, we have an empty array again, so we have no users stored in the database. In this section, I'm going to show you how the one-to-one relationship models in web APIs work in ASP.NET Core. We are firstly going to create the models, and then we'll handle the methods in order to perform all of the CRUD operations with them. So I'm just going to open the previous project that I did for the CRUD operations in web APIs. And there I'm just going to add the one-to-one relationship model to it. So I'll wait for it to load. And here you can see that we have created the users controller with the methods there. And we have added services to a service to our project. And here are the methods of the service. If we go to the models, we have only one model, the user model, with all of these properties. And here I'm going to add an other model for the one-to-one relationship. And I'm going to name it the username model, so that the user has just one username, and the username is only related to one user. So this is the one-to-one relationship as an example. And to this username model, I'm just going to need an int ID property. And I'll have like a name property for it. Just these two properties. Okay, I'm just going to make the name property as nullable. So it could be null, but then otherwise I'm going to need to connect this to the user model. So I'm going to need the user ID int property. And then I'm going to need a user property. I'm naming it user. And here on top, we're going to need to specify also the data annotations that say that specify the foreign key to be the user ID. So here, if we go to the users model, we're also going to connect the user model to the username model. We're going to need a username ID int property, and also a username property, which I'm also going to name username. And we'll make both of these nullable, so that when we create the new user, maybe we don't need to specify it right away. So it could be null. And what is left to do, each time when we create a model, we need to add the migrations to the database. So I'm just giving it a name so that we know why we did the migration, like one-to-one, because we added a one-to-one relationship model. Okay, so the migration was added, so we just need to update the database. Okay, it seems fine. What you're going to need to do now is, if you remember from the previous video, when we wrote this user DTO class here, we're also going to need another class in order so that we can specify a way to show the data now that we have also a username property to the user. So I'm just selecting a name for this username DTO data. So the idea is that the user will be shown with the username as well. Okay, so username DTO. I know this is a horrible name, but nothing better was coming to my mind at the moment. Okay, so in this, in the user DTO model, we want to add the user ID property, so that each time when we create the user, we also specify the user ID. Okay, I'm just going to copy what we had in the user DTO, and here now, I'm just going to add the string property so that we just show the name of the username for the user. So we don't need the username ID, we could just show just some specific data, which is actually the purpose of the DTO, so that we show only the data that we want. And this username property, I think, needs to be nullable because that's how we specified it before. Okay, so if we go to the user service, where we added our methods for the CRUD operations, we see that in order to display the data as a user DTO, we wrote this user2DTO function, and to it we're gonna need to add this this username ID that we added to the users model. Okay, this was just my bad. This was username ID, not user ID. In the user DTO class. And back to this here, we're gonna need to have a username ID in this user2DTO function. So we need to specify there, we need to take from the user the username ID as well. There's an error, maybe we haven't specified the username ID property somewhere as nullable. Okay, so this here needs to be nullable because in the user we specified it. As we see here in the user model, we specified it as nullable, and we need to do the same thing in the user DTO. So just make a question mark there to make it nullable. We'll go back to the user service for our methods. Here in the first add method, we just need to, when we create the user here, we need to take from the user DTO the username ID as well. So username ID equals user DTO dot username ID. And the first method, the add method, has to be okay. We don't need to make many changes there. The delete method, we don't need to make any changes at all. So here we won't show the data as user DTO because they don't have this one-to-one relationship type. We're going to need to show them as user with the username DTO that we created. And here we can write this method in the context that users.select. Here we're going to create a new username user UN DTO, which was the DTO with the username included. Here we are gonna need to make a few changes. Okay, so we will store this in a user variable. And down there, we're gonna return this user variable. And inside here, we're gonna create the user UNDTO, where we're gonna take from the users, from the context, we're gonna take the user's first name and assign it to the first name of this user UNDTO model. We're going to do the same thing for the last name, for the age, for the personal number. And in the last step, we need to do the same thing for the string username that we created. And we're going to need to select here username. Username equals username dot name. So the name of the username model. So the getAll method is fine. We see here a red underline error because the return type of this method is user DTO, not user UNDTO. We're going to need to change that here. We're also going to need to change the iUser service interface in the interface. The return type has to be user UNDTO because we are returning a user with the username. Also, we're going to need to change this here in the controller as well. The getUsers method, where we use this getAll method that we had in the service. Okay, the getAll method is fine, and we can do something similar here in the getById method. We are going to need to change just a few things. First of all, here we need to add a where clause where we select just one specific user from the context, the user where the ID is equal to the ID that we take in the parameter. Okay, so what we need to change here as well is to make it that first or default async. So we're just gonna return one user from the context. Or we will just create one user from all this thing here. And the return type has to be also user UNDTO. And we'll change this in the interface and in the controller. So here in the getById method signature here, just tab, and in the users controller in the getUser method. If we go to the update method, we only need to add something here for the user that username ID. So we will check, we will update also the username ID here. Okay, username ID equals user DTO dot username ID. We can just run the project now. And we'll check if our methods work. Okay, if we go to the get users endpoint, here we can try it out and execute, and we'll see that I guess we have no users here, so we have this empty array. So what we could do here is I'm just gonna see the name of the database here, and we can just go to the SQL server. So we can go to SQL Server Management Studio, and we can create a user, we can create a username, And we can connect this together so that they have a one-to-one relationship with each other. And we can then see how this data appears in our APIs. So just click on connect. I'm opening here the databases, and the name of my database was something like CRUD API data. And open tables. And here I'm going to go to the users table, dbo.users, and click on edit top 200 rows. Okay, so we can here create a user model with a first name, a last name, a name. We'll fill this data here and we'll connect it with a username ID of 1, which we'll create later. Okay, so one user was created and it has an ID of 2. We can just go to the dbo.username to create a username and to connect it to this user with the ID of 2. Okay, just let me put a name to the username. And like, yeah, John Davis, and the user ID will be 1, will be 2 actually, which was the user's ID, that the ID of the user that we created. Click enter. Okay, so username with the ID of 1 was created. And just go and test our application. Okay, if we go here, we can try and get the users firstly. So we have the first name, the last name, and we have also the username as the name of the username displayed. We can go to this get user. We input there too, and we get the user that we inputted. We can go and try to post the user. We can click on try it out, and here give a first name to it, a last name. And okay, we'll fill this data, and there in the username ID, we'll just also connect it to the one username, because we only had created one username. Okay, we can go and try to update the user. I don't really remember the data of the user, but we'll just update the second user, the user with the ID of 2, and give the username of 1. And if we go and get the user with the ID of 2, the data will be changed as we see here. We'll also try and delete actually the user with the ID of 1. If we had the user with the ID of 1, we actually had no user with the ID of 1. I think the user with the name Max took another ID. If we could check this when we created the user, we can see here in the response header that it had the ID of 3. And if we try to delete the user with the ID of 3, we have received no content here. But if we go and try to get all of the users, click on execute here, and the second user will be deleted. In this section, I'm going to show you how the one-to-many relationship models in web APIs work. We're going to start by creating a model, then we'll modify a bit the data transfer objects, and we will handle the methods as well. So we can just go to the models and see that we have a user model that we connected to a username model before in the previous video. Now we're gonna need to add another model so that we can make a one-to-many relationship model. So we will create one post model. So one user can have multiple posts, but one post could be only associated with one user. And for the post model, I'm gonna need an int ID property. And then I'm gonna need something like a string property for the content of the post. So this could be like a tweet or something, a comment, or something similar. And I'm gonna make the content nullable, so it could be null. And the last thing I need to do here is just to connect the post model to the user. So I'm gonna need an int user ID property and the user property, which I'm gonna name user. And here above, I'm gonna need to write the data annotation to specify the foreign key, which is gonna be the user ID. Here in the user model, now I'm going to need to connect the user to this post model. So I'm going to write here public list. So user can have a list of posts. And I will name them posts, and I will make them nullable as well, because sometimes the user maybe hasn't posted anything. And each time we create a new model, we need to go to the context of the application here. And we're going to need to specify a dbset instance for the post model. So dbset post, and I'm naming it posts. And we can go to package manager console and add the migrations. We can give them the migrations a name like one-to-many to know that we did these migrations when we added the one-to-many relationship model. And now we can just simply update the database. Okay, is it done? Now it's done. We can go to the DTOs. We can go to this username DTO that we had created in the previous video here. So this is how the data will be shown to us. And what we can do here, we can add this posts property from the users so that we will see for each user the posts that the user have. So I'm just adding it here. And I'm actually going to name this because this is not really a good name. I'm just naming it user display DTO. So, and I'm clicking here yes, so that this name will be changed everywhere where we had used that DTO. So the function we have created here was to turn users into user DTOs, because we would need to do this in almost every method below. But now that we also have other DTOs, we can do this process inside the methods, just like we will do now inside the getAll and getById methods. So we don't need to make a modification to the add method. It's okay how it is in the delete method as well. So we will only modify the getAll and the getById. So here we need to add another line. We will take from the users in the database the u.posts. So we'll take the posts for each user, and we can click on toList to list all of the posts that the user can have. So here in this method, when we loop through the users in the context and we create the user display DTO, we will just assign to the posts of this DTO each user's posts. Okay, so we can do the same thing here when we get only one user. So it's a similar process, just getting for that one user the posts of the user. So it should be pretty much fine. Now with the methods, so what we can do now is to go to SQL Server Management Studio and create posts, because we haven't created any posts, and we can associate these posts to the users that we have so that we can see how the data will be displayed then. Okay, so we click connect and we just need to find our database for the project, which was this CRUD API data, as I remember. And then just see the users firstly. So click on edit top 200 rows. Okay, so we only have one user here. Then just create one more just so that we can see more than one user. So I'm giving it a name, Ian Parker or something. Okay, let me just remove this. So Ian Parker. Age of 20, a personal number, and I'm connecting it to the first username because I don't think I have another username. But let me just go to the usernames and do this correctly and create another username. Actually, it would be better. Okay, so I have only one username here, and I'm making another one, Ian Parker, and I'll connect it to the 1002 was the ID of the second user, as I remember. So let me just go here and specify here the username ID and set it to 2. Okay, let me just go to the posts now. And okay, here I'm gonna create a post. In the content, I can just write like a first post, something. So I'm setting the ID to 2. And I'm creating another post, like a second post, and connecting it to the user with the ID of 1002. This looks fine. We can just go run the project and see how this data will be displayed in our web API. Okay, we have here the Swagger UI, and we can go to the get users endpoint, click on try it out and execute. And here we'll see the 2 users that we have. We see how the posts are displayed. So we see that we have displayed the ID of 2, content, first post, and then the user ID of 2. And we have all of the, we have the details for the post for the second user as well. We can go and try this in the get, to get a specific user. And we can see how the data is displayed for a specific user. But sometimes, I mean, maybe you would not want to show all of this data for the posts of a user. So like the ID of the post and then again the user ID. So we can go and modify actually the user display DTO. So we won't display a list of posts, but we can just display a list of strings, for example. And the strings will display the post content. I'm naming it post content. And we can go to the user service to modify the methods. So in the getAll methods, we will need to specify the post content property and set this to u.posts.select from the posts of the user. We will select only the content, so p goes to p.content. So for each post that the user has, we will just display a list of all of the contents of their posts. The same thing we're gonna do for the getById, for the getById method. And we can run the application and check now. Okay, we'll try it out, execute, and we'll see a list of the users that we have. And here we see that only the content of their posts are displayed. But we can go to SQL Server Studio and add another post, for example, to the first user. So like third post, and I'm connecting it to the user with the ID of 2. This way we can see how the data will be displayed when a user has more than one post. So let me just turn on the application and go to the Swagger UI, refresh it. And if we see here, we'll get data for the user with the ID of 2. We see here in the post contents, we see here the first post and the third post, which are the name of the contents of the post that this user has. So yes, that was how one-to-many relationships in web APIs work in ASP.NET Core. In this section, we are going to create a many-to-many relationship model. Then we'll handle the methods and the way to display this data. So let me just go back to the project. And I'm just going to go to the models and add a new model. Let me just see the users model firstly. Here we have a users model. We have added a one-to-one and one-to-many relationship here with username and posts. And I'm just going to need to add another model, which is going to be a many-to-many model. And let me just create firstly a community.cs class or model. So one user can be associated to many communities, and the community may have different users. This is the idea behind it. I'm just going to need an int ID property first for the community, and like a name for it would be enough. But in many-to-many relationships, we also need like a helper model, like a middle model. In our case, I'm going to name it user community. .cs, and I'm going to create it. Here we need firstly an user ID int property and the user property, which I'm going to name user. And I am pretty much doing the same thing for the community as well. I'm going to need an int community ID property and a community property as well. This is similar to what we have done before in the MVC in ASP.NET Core, and that's what we're doing here in Web APIs as well. It's the same kind of logic, it's exactly the same structure. If we go to the users class here, to the users model, then we're going to connect the user to a list of user communities. So we're going to connect it to this middle or to this helper model. I'm going to name it user communities. So the user will be connected to this helper model, and then it will be connected to the community model. I'm going to make it nullable so that the user maybe doesn't belong to a community or something, and we don't have a problem when creating it in the beginning. And we're going to paste the same thing in the community model as well. What is left to do now is each time we create a new model, firstly we need to go to the context and create a DB instance. Firstly for the community, a DB set instance. So firstly for the community, I'm naming it communities. And of course, we need another one for this user community helper model, or like middle model. And I'm also going to name it user communities. Just like that. And always when you create a man-to-man relationship model, we need to specify this relationship in a function here in the context. The DB context has a method called onModel_creating, which we're going to use, that takes an instance of model builder as a parameter. This method is called by the framework when our context is first created in order to build the model and its specifications in memory. So we're going to need this to write the specifications of our many-to-many relationship models. So we're going to need to create a method here. This is the protected override void, and the name of the method is onModel_creating. So firstly here in model builder.entity user community, we need to specify the foreign keys or the keys. So we click on has key. You see for user community, and this goes to a new. So you see that user ID, so we specify all of the keys that this user community model has, which are the user ID and the community ID keys. And here below we need to specify a few other things. So model builder.entity user community, inside of it. So that has one, and here we are gonna write the name of the first model that is connected to this user community, which is a user model. And this user model is connected with many user communities model, which we will specify inside here. So these user communities here is the name of the dbset instance for the user community, not the name of the model, just so that you know. And then we have to specify the foreign key of this user model, which is the user ID. That's the idea, that's the logic behind it, and we'll do pretty much the same thing for the community model as well. So I'm just copying it down and paste it here and just modify it. So that has one, we write here the community. The community is connected to many user communities, and the foreign key that the community has is gonna be the community ID. Okay, so now we can go to package manager console and add these migrations. So add migration, and we can give it a name so that we know why we added the migration. So like many-to-many, because we added a many-to-many model to the project. And we can simply just update the database now. Okay, it's done. We can go to SQL Server Management Studio because we don't have data for the community, and we need to connect the users to the communities in this user community model. So we'll do that manually in the database so that we see then how the data will be displayed in our API. So click on connect. Here, let's just go to the databases, and the name of my database for the project was this here. I'm going to the tables. And firstly, let me just see the user that I have here. So edit top 200 rows. We can go and create a community. So go to communities, edit top 200 rows. I mean, community is just something like a Stack Overflow community or like GitHub or whatever the name of the application is. We can go to this user communities model and connect these two with our two users. The user with the ID of 2 to the first community, and We can connect it to the second community as well, because it could belong to many communities, and we'll connect the user ID 1002 with the first community. Let me just go back to our project and simply go to our DTO to display this. So to specify the way the data will be displayed, so we will display a list of strings so that we can display only the names of these communities. So I made it nullable and I'm naming it user communities. I'm just going to need to go to the user service and only modify the getAll and getById methods, because there we specify how the data will be displayed. So here, user communities will have the value of the user communities and select, and there we'll select the C that goes to c.community.name, and then to list all of the names of the communities that the user is in. And exactly the same thing will go to the getById method. That's why I'm just copying it down and pasting it here. Okay, let me just run the project and then we will shortly see how all of this looks in our web APIs. If we go to the get users endpoints and click on try it out and execute, we'll see how this data will be displayed. So here we see how the user communities are displayed as a list of strings, and down below as well. And we can see this for a specific user in the get users by ID endpoint here. So yeah, we'll see this for the second user, how it is displayed. In this section, I'm going to show you how to call your own web API that you create and use it in a project. We're going to do a simple to-do list project to demonstrate how you can interact with the data from an API. We're going to have to make the HTTP requests using the fetch function in a JavaScript file. And I know JavaScript is not the purpose of this YouTube series, and maybe some of you are not familiar with it, but it is important to have an idea of how this whole process works. For this reason, I'm going to pretty much copy a project from the .NET documentation, where I'm going to take the HTML and JavaScript files, modify them, and I'm going to explain you what they do. This way we won't make them from scratch, because the video would take too long, it would lose its purpose, and this way everyone could follow along and implement this in their projects, even if they don't know JavaScript. So let's start working right now. So let me just create a new project. We're going to select an API template, ASP.NET Core Web API, click on Next. I'm giving the project just a name, like a to-do API project. Click on Next, and I'm going to leave everything as it is. So the project is loaded. I'm just going to delete this class that is here by default, and the controller that we can find here. We don't need them. The first thing I'm going to do, I'm going to add a modules folder, and I'm going to add just one module for our project, the to-do item module, actually. And we're going to create, firstly, we're going to create a web API with this module. Then I just give here the name of the module. To-do item.cs. And the module is going to have a public int ID property. We'll need a string name property for the name of the to-do item. I'm gonna make it nullable with the question mark. And I'm gonna need a boolean property to specify if the to-do item is complete or not. So next, we're gonna need to go to the project root and add a folder named data, where we're gonna input our context for our application. Naming this data, and I'm gonna create a class inside of it for the context. Okay, I'm naming it to-do context. Okay, the to-do context class is gonna need to implement DB context, for which I think we have to install here the Microsoft Entity Framework core. Just wait until this installs. Okay, right now we need to specify here a constructor, like this, what we usually do when we create a context. Inside of the constructor, we write db context options with the name of the context inside, options, and then base options. This implements base options, and yeah, that's pretty much it for the constructor. Below, we're going to need to specify the dbset instance of our to-do item model that we created. We're going to need to give it a name here for our to-do item dbset instance. And I think we're going to need to import in the project the models folder, the models directory. Okay, so if we go to app settings.json, we haven't connected this to we haven't connected the project to a database, so let me do it just here. Go to Server Explorer, create a new database, and for the server name, I'm going to need to open up the SQL Server Management Studio. Okay, here's the name of our server. Let me just copy this and input it here. I'm just giving a name to our database, like whatever. Okay, now if we go to our here and click on properties, you can find here the name of our connection string. And here we can input it in connection strings. Here we can give a name to our connection string, which I usually do like just default connection string. Let me just copy it one more time here in the properties window. Let me just paste it, and here I'm gonna need to specify the encryption to false because we don't have a password when we connect it to our database. Okay, so what is left to do now is just go to the program.cs file, and we will add the service to connect our context with the connection string. So here we're just gonna write builder.services that add db context. We're gonna write the name of our context, and inside of here we're pretty much just connecting our context with the connection string. Here we put the name of our connection string. What else we need to do here is, as we can see here, we haven't installed the SQL Server dependency, so we can just go to dependencies and manage NuGet packages. Here we can just click on SQL Server and we will need to install this. Just click on accept. Okay, we just also need to install the entity framework core tools to be able to access some data that we need when we add migrations and update the database. So just install this, go to program.cs, and we can see that here we just need to, I think now just need to use entity framework core, and it all works just fine. Just go to package manager console here and add the migrations, give it a name. The migrations were added, just need to update the database, and that's gonna be it. Okay, so now if we go to the controllers folder, we can add a controller, and we're not gonna do it ourselves, we're gonna use a template. If we go to API and API controller with actions and add it, the controller will be added. Here we just need to specify the model class and the DB context. Click on add, and we will have all of the methods to do the CRUD operations in our controller. We're not using a service in this project, which would be great if we would do the project for production. But in our case, for what we're doing it, just a controller would be fine, and that's why we're creating it with a template. Okay, the controller was created. Here we can see all of the methods that it has. We'll try and run the project. Okay, here we'll see the Swagger UI, and we can just test it if everything works okay with our web API that we just created. We'll click on execute. We should see an empty array here in the first endpoint. So yeah, we see an empty array. We could actually just input something in our data so that we have something. Just click on try it out here in the post endpoint and give a name to a to-do item, like do groceries or something. They're making these complete property attribute to false. And I think this was created successfully. You can check it in the first get API to the items endpoint, and there we see our data. Okay, so now what we're gonna do is go to the root of the project and add a folder where we're gonna add all of our CSS, HTML, and JavaScript files. So this is a practice that we make them inside the www.root folder. Then we're gonna add a folder for the CSS. Same thing for the JavaScript as well. Instead of CSS, we're gonna need to add new item. We're gonna need to find here a CSS file. If we go here to web, think. Get to content, we see here style sheet, which is a CSS item. Click on it, just name it like site.css and add. The same thing we're going to do for a JavaScript file. Just add a new item. We're going to find here a JavaScript file, name it site.js. And there it is, and in the root folder we're going to add a new item. We're going to add an HTML file, an HTML page. I'm naming it index.html page. Here it is, just a boilerplate, just some normal HTML file. If we go to launch settings.json, we have here the specify that when we run an application on HTTP or on HTTPS or on IIS Express, on whatever we run the application here, we see that the launch URL here is Swagger. So by default, the application will be run with Swagger. And if we remove it here, when we run the application will actually run on an index.html file that it finds. So if we try to run the application, here this won't take us anywhere because we need to specify something in the program.cs so that we can use static files, which are HTML, CSS, and JavaScript. So now it won't work. Okay, so let me just go and find in the .NET documentation the project, the to-do project that we're gonna relate to here. We go to this web API with JavaScript, which shows you how you can call your own API in a project. And here, if we see here, we have to use default files and use static files in order so that the project will be run on the so this index.html file will appear when we run the project. And if we go to program.cs and paste it down here, now if we run the project, we will see our index.html file, which was basically empty, and we are not supposed to see anything. But yes, this is what we should be seeing. Okay, so if we go again to this .NET documentation here, this is a project similar to ours, similar with our model and with the web API that we created. But now we'll see here the index.html file that this project has, and I'm copying it. So I'm just gonna paste what I copied from the index.html file to our project. And I'm gonna explain you what these things do, but firstly, so that we can see this function. This is an option to add to the items and to see them and to edit them. But we're gonna have to actually copy the things from the CSS and the JavaScript file so that it actually works. And then I'm gonna explain them and modify them a bit. So I'm just copying the CSS file, pasting it down here. Just click on save, Control save S, and I'm copying the largest file, which I don't know, this has like 200 rows, 200 lines of codes, and I'm going to explain what this does here. But so that our page is functional, I needed to copy them in the beginning. So now if we see here, we see in our list, we have our do groceries item that we had created before. So here, each time we add a new item, we make an HTTP request from the JavaScript file to our web API. and it stores the to-do item in our web API. And down below, we call all of our items in our web API, and this way they are shown. We can edit them here. So when we click on edit, this edit box appears where we can edit our things here. We can delete them, we can make them complete by marking this checkbox on the left. And this is pretty much what this does. Okay, so I'm gonna start making it a bit visually better. So just naming it to-do list. I'm gonna actually need to go to the Bootstrap to import the Bootstrap, and because this way I can make things a bit more better visually. And put it on top here on the header. And I'm gonna put all of the elements of our page in a container div so that they are a bit more better. They have a better spacing. Just a div with a container class. And I'm putting the div pretty much in the end of the body tags here down the table, so everything is inside this container div. And if we save it, here we see things are a bit more centrally spaced. Yeah, I'm gonna need to put pretty much everything inside the div and to make them in the center of the page. So I'm just making them visually better at first, and then I will explain what they do. So I'm giving the class, I'm making a flex box, this bootstrap class, so dflex, and then justify content center is also a bootstrap class. We should pretty much put the title in the center of the div. And we need a margin of 3 to have a bit spacing. I need to close the div. I'm copying it because I'm gonna need it to paste it in everything below as well. So I'm just closing the div here. I'm gonna delete this add header, we don't need it. I'm gonna put the form here inside the div as well, giving it a bit of more of margin. And I'm closing the div. Okay, we see things are centrally spaced, so they're in the center of the page. Now we're gonna need to do the same thing for this edit form that we don't see now, but we see when we click on the edit button, because this is what we have, what is being done in the JavaScript. In the meanwhile, we're gonna need to we can add a class to this button info to this add button, so it looks visually a bit better. This is a bootstrap class as well. Okay, now we're gonna need to center this edit form here. Okay, just the same thing again. Now it's in the center of the page. We can give this save button a class of, we'll make it like a green because it's a save button, like button and button success. As you can see here. And this paragraph of counter, which counts the amount of items which is being done in the JavaScript, and we can center it as well. I'm just going to delete this table header, they don't look good to me. Okay, so we'll do just the same thing with the table here. Everything is centered now in our HTML file. Then I just try to add another item. The counter is updated. And just to see here how things work in this first form here, we add items. So in this form, if we see this post form, and you see each time the form, the submit button is set, the set item function from JavaScript is being called, and this action JavaScript void that you see here just basically says that nothing will be called because a method in the JavaScript would be called in this case. And we see here the same thing in the edit form here, where we take the ID, the checkbox, the text. We will send data to basically we will just call this update item function here. Here we see the counter and the to-dos in the table. Then in the end of the file, we see this get items function that is being called from the JavaScript that we have in the JavaScript, which will be called. And now just let me fix a bit the site.css file. Okay, so this sets the edit form to none, to the display to none, so that we don't see that in the beginning. I'm just going to delete a few things that we don't need here. For the table, I don't think I need any of those here. I'm going to remove the borders as well. Okay, what I can do in the HTML and body text inside of it will just give a nicer background to our page. The background image is going to be actually it's a page where you can see linear gradients simulator. So this is just so there are specific pages where you can simulate these different backgrounds, and you can take the code from there. So here we see here, I know it looks like a good background. This kind of gradient, linear gradient like background, and I can just copy the code here and paste it. And we see our application here. Okay, I'm just gonna need to paste it in the beginning, and the page looks actually good in my opinion. Okay, in this star here, which specifies basically everything in the page, I can make the color of the text to white because the black color looked a bit not good in this background. But I will need to specify here in our forms that are white, we don't see the text. So I'm just going to need to go here to our add and edit forms and specify the style of the text to black. Style color to black. This way we can see here when we import the text and do the same thing down below in the edit form. We can try and edit things, but yeah, they work well. Now it's actually the hard part of the application. These functions that we had in our index page, all these functions are specified here, and you don't, because JavaScript you maybe don't know, but you can see the idea of things here, how they work. So in the top of the page we have specified this URI, which is the address of our web API where we make the requests, and we have an array with our to-dos. So here, I don't know, here we can see the to-do items, API to-do items, which is the address of our web API where we do the HTTP requests. Try and add something there. And if we see here, everything is displayed again. Each time we add something there, we make a request to this address of the web API, and here we see that it is shown here, it's displayed here. If we see the first function, get items. This fetch function, JavaScript function, fetches, has as a parameter this address URI, and it takes a JSON from it. And then if the request was successful, this display items data function is being called. And if the request was not successful, this catch console.error will be invoked, and we see this in our console. But if this was successful, the display data would be called, the method. Then we just make the screen bigger. Here, the display items function would be called if the request was successful. And what we do here is just get the to-dos, the div with the to-dos as an ID that we had in the index page. And then this display count method function here is being called, that displays the items that are the number of items that we have, this one or two to-dos, which takes data.length as a parameter. Then we have a button created above for each item inside this data that we have in our web API. An input would be created, firstly a checkbox input. It's going to be disabled, and it's going to take this property item, that the isComplete property that the item has. Then an edit button would be created, would take, when it's being clicked, when the edit button would be clicked, this display edit form would be invoked, and the same thing is going to work for the delete button. A delete button would be created for each item. When it's being clicked, this delete item function would be invoked. And then we see here that whenever, for each item, a row would be created in the table, and in each row, basically all these lines here do is just for each row they add this checkbox, this text, and these two buttons, the edit and the delete buttons that we have here. And we can go on top of the page and see here again the add item function. So whenever time we add an item, we have here an object that takes the values of that item, and a fetch function here would make an HTTP request to the URI, to our URL. The request would be of type post. The headers contain the information of what would be accepted in the content type, and then this JSON.stringify item just basically turns our data that we put in our web API that we sent and makes them as a JSON string format. And then if the request was successful, we just get the items and just get all the items again. In the delete item function here, we just go to a specific URL with an ID and delete that element. And then if it's successful, we get the items. If not, we get an error. And the display edit form, which was invoked when we clicked on the edit button here, just will take the value of that elements, the ID, name, the check, if it's check or not, and will be setting the display to a block. And here we see the update item function when we update an item here. So we just take the values of that item that we have updated, and we make a fetch, and in the fetch function below we make an put HTTP request to the web API. We specify the headers, we put our data, we make our data as JSON string format with this JSON.stringify item, and the same things. Then we get the item, and just like in other functions, I will just be doing another extra thing for the design of the app. I usually use this font awesome library a lot when I do things in the front end. And if you find, you can firstly just import this link, this library, and put it in the HTML file here, just in the header. And this allows us to put icons in our application, which are just visually very great looking. So this edit and this delete buttons here that we have, they are created from the JavaScript for each item. So we're gonna need to modify them in the site.js file. So here we can remove this inner text. We don't need to have a text in there anymore, and we can make it like edit button.inner HTML, and here inside we can put the icon tags, actually, how they are written in HTML. The icon tag I'm going to use here is going to have a class of FA pen, which you can see in Fontason website, which is just the icon of a pen, basically. Below I can give this edit button a class, which I can do by clicking that class list, that add, and inside I can add multiple classes to it, which are going to be button and button info or something. So they look pretty much the same as the background. You can see the pen better. If you click on save then. Okay, just updating it here. And we can see these icons that look pretty much better than it would look with just an edit text there. We can pretty much copy this and modify it to do the same for the delete buttons. The name of the class of the icon would be FA trash, and the class of the button would be button danger. So it's this red bootstrap class. Okay, here I just need to make it delete button, not edit button. Not leave it as it was. Now if I save this, we can see that both of the two icons working pretty much well. And this is the end product of our application. So that was all for this project. I hope you know now how you can implement your own web API in your project. In this video, we're going to see how we can integrate ChatGPT to our own project in ASP.NET Core. OpenAI, which is the team behind ChatGPT, have added ChatGPT to their API, and they have provided us with a very simple way to use it. We'll call this API inside our Web API project in ASP.NET Core, and we will get responses directly from ChatGPT. So let's just start right now. So I have just opened up Visual Studio and I'm creating here a new project. Let me just find the Web API template for our project. And I'm going to use the first one with a C# as its language. Click on Next. Here I'm giving a name to the project, like, I don't know, OpenAI app or something. And just click on Next. I'm leaving everything else here as default and just click on Create. And we'll just wait until the project loads. Okay, so I'm just deleting some this default controller that we have here. And this default weather forecast class here. And what I'm going to do, firstly, I'm just going to go to dependencies. I'm going to click on manage NuGet packages. Here I'm just going to add the OpenAI package. Just click OpenAI here and just click on install. Click on accept. Package is already installed, and just go to the controllers and add a new controller. Here, I'm just go to API and I'm gonna add an API controller, empty. Here, let me just give a name to the controller, like home controller. And this is our controller. Now, before we can create the method, let me just go to platform.open.ai.com, which I will link down in the description. And here you should firstly just sign up to have an account to be able to use their API. It's a pretty straightforward process. I have already an account, so I'm just logging into it. Just inputting my username and password. And after you have successfully logged in, just go to the right top corner and click on View API Keys. Here I have already created an API key, but I'm just gonna create a new one so that you just see how it goes. So I'm naming it like whatever, creating the secret key here. And this is the only time we will see this, we'll have to copy this API key. So I'm just gonna copy it here because we cannot see it again. So I'm just copying it here, click done, the API key is created. I'm just storing it somewhere in my computer so that I have it. And I'm just going now to the controller where we'll create the method to use this API key. Okay, we'll just create a HTTP GET method. Down below, I'm just specifying the route, which will be equal to the name of the method actually. So I'm naming the method and the route used ChatGPT. And here I'm just creating a public async method. The return type will be task and it will take an iAction result. Here's the name of the method, which I'm making it use ChatGPT. And the method will take an input actually. So a string, which I'm naming input here. Then let me just open up the curly braces. First, I'm going to need an output variable to store the output that we receive after we call the API. And I'm just giving it an empty string value here. Then inside another variable, which I'm naming OpenAI, just going to create a new OpenAI API class, which will take inside parentheses our secret API key inside double quotation marks. Here's the key that we created in our account. Here down below, what we will do is we will create a completion request object. Just naming it completion request. And it's basically the syntax to do it. Here we'll also specify some properties of this completion request that we will send to the API. So the completion request dot prompt will be equal to the input variable. And here I'm also going to specify the completion request dot modal property, which I'm just setting it to OpenAI underline API dot modals and that model, and then that I'm just using one the DaVinci text, which is one of the models choices. And down below we can also specify this max tokens property, which basically specifies the maximum amount of characters that the response can have we will set it to have a maximum of 1024 characters. Down below, in another completions variable, we will actually make the request to the API. So I'm just adding here await openai.completions.create completion async, and it will take the completion request object in parentheses. So here we'll make this request to the API, and we will also await there in this variable the response that we will get from it. Down below, after we have gotten the response, we will use a for each loop to loop through this completions variable. I'm just opening up the curly braces, and to the output variable that we created in the beginning, we will store there each text that we will get from this completion variable. Just need to write it completions so the variable name .completions. What is left for us to do now is we'll just return the 200 code, the OK code, together with the output variable. This is all the code we have to do here. So if I just run the project here, we should be able to see our Swagger interface. We will test our API that we created. So we see the name of the controller and this method. This is actually ChatGPT, not ChatGPT. I can just simply change that. ChatGPT. Okay, let me just run the project again. Okay, let's click on this method here, click on try it out. You will put an input to it, to the API. So like whatever you write in ChatGPT, like, I don't know, hi ChatGPT. If we execute it, we make the request to the API and we should get the response. Down below, we have the 200 OK code, and the response body we see, hi there, how can I help you? You can try different things. Anything you ask ChatGPT in the website, you will get the same response here as well. So this was pretty much it. This is how you can integrate ChatGPT to your web API project. Thank you for watching. Make sure to subscribe to the channel and like the video if you like this content. And I will catch you guys in the next video.